Yeah, hi guys. So today I will introduce you how to run this StimOpti software. First, what you have to do just click here to beginning, and like your login page is there. So what you have to do, you just enter your username and password that provided by Petroleum Soft. So like I have entered this password and click here to login. Now, what you have to do, just click on Create Project tab. In this tab, when you click it, there are some basic informations about your well, like in which model you are run this simulation process. One is carbonate model and another one is sandstone model. You enter your project name is here. Like I have entered the project name is test case. Yeah, the well name like AX100, something like that. Field name, you have entered your field name like you enter the field name is petroleum field. Okay, you enter your field name. And now when you come to the field type is you select your onshore field or offshore field, and unit system, in which unit system you are working. You are working in field system, you are working in metric system, means the units in meters and unit in field. So you can select from here. Now come to the well profile. Well profile, your well is vertical, horizontal or slanted. So you can select one of them. And now come to the completion type. Completion is open hole is there, cased hole is there, limited entry is there, slotted liner is there, sliding sleeve is there. So for this case, we just go for the open hole. Now pumping methods. In pumping method, there are two methods. One is bullheading and another one is coil tubing. We select bullheading, and when you click on this create button, all the tabs are filled. And when these tabs are filled, you just click on create button. Now this is your main tab where you enter your data of, like, first we go for the reservoir data. In reservoir data, there are two options. One is you can download Excel from here. If your data is too long, you download your Excel from here, and you enter your reservoir data in this Excel, and you just choose your file and import it. One option is there, and second one option is there. If your data is too small, you say enter your manually. Like I have entered here manually. For this case, we go for the some examples like 10280 is there, 100-foot formation is there, TVD is there, porosity is there, permeability is there, pressure, sonar pressure, damage skin is there, and kh by kV ratio is there. And when you enter all the values, just click on the save button. First line automatically, first one will save. Or you can go for the second zone, same thing. You can go for the second zone like I have done here. Your porosity, your permeability, the solar pressure, your damage skin, and your kh by kV. When you enter all these values, just click to the add button. All the size zone one will be automatically added. After enter all the values, you just click to the next button. In next button, what you have to do, next tab is open. Like that time you have select vertical well and open hole. So only vertical well and open hole data will show here. You just enter your wellbore radius. We enter our wellbore radius and then click to the save button, and you enter your production tubing in a diameter. You can change your production tubing length if your production tubing length is different. That comes here. This because this tubing length is automatically calculated by our software on the basis of some your inputs that you are providing at the time of your survey data. So we just go for the production tubing in a diameter and then save. And when this tab is completely filled, you just go for the next button. Next tab will open. The next tab is pumping data. In pumping data, at that time you are selecting your injection type is bullheading. So in bullheading, you just enter your friction gradient value. That value is psi per 1,000 feet. It means in 1,000 feet how much friction is there. So for example, we enter a value that is 45 for this case. Then save it. Now come to the next. Yeah, in acid properties, there are different fluid is there. HCl is there with different concentrations 7.5, 10, 15, 20, and 28. Alcoholic acid is there. HCl acetic acid with different concentration is there. Med acid is there. Emulsified acid is there. Chelating agent GTP, GLDT, HEDT is there. And one user defined fluid is there. Means you can enter your values according to your when you select the user defined. So we just go for the SCL15. Yeah. And when you select the SL15, all the values will come here on the basis of SL15, like diffusion coefficient, concentration, viscosity, and specific gravity. And you select your main fluid, just go for the next button. In next button, the upper part is selecting for the fluid that you have run on the base time, means to do at the time of mean treatment, which type of diverter you have to select. You can select like for this case you just go for the foam, for example. And if you want to do sensitivity, check which diverter is giving your best diversion. If you want to do sensitivity, just select one of them or you can select both. And when you click to the save button, all that four diverter is here. Can if you have a diverter, you have some basic proper different basic properties of like foam quality, foam viscosity. If you have some values, you can edit and change their values. If you don't have these values, you just go for the default values. Viscosified, like K is here, N is here, viscosity is there. So you can change it. In VS diverter, calcium maximum concentration, SDVA concentration, VS pH is there. In particulates, cake porosity, grain size, particulate viscosity is there. Okay, so you can change the values if you have. If you don't have the values, you just go for the default values. After selecting this tab, you just click to the next button. The next tab will open. In next tab, this is a damage type tab. In which type of damage present in your formation, like emulsion or wettability change is there, asphaltene and plafond deposition is there, open hole perforation or gravel pack is there, or deep elbow damage. It means which type of damage is that present in your reservoir, in your formation like. So we just go for the open hole because with that time we select the open hole, like our damage is open hole. In open hole, there are two methods there. One is crude oil incompatibility is there or formation water incompatibility is there. So we just go for the formation water incompatibility. When you select these parts, automatically fluid will select for the pre-flush. Like in SCA, in at the time of pre-flush, KCl brine 1. Which type of KCl brine 1 you have to go for these fluids? NH4Cl is there, fresh water is there, or diesel oil is there. We just go for the fresh water. Okay, and at the time of um, fluid selection, in this is a post-flush fluid. In post-flush, which fluid we have to inject at the time of post-flush, we go for the fresh water. This is just example. You can select any one of the fluid for the pre-flush and post-flush. You can click to the next button. Yeah, this is your rock property tab. In rock properties, you enter your fracture gradient value, like here for fracture gradient 0.75, temperature like 180 degree Fahrenheit, rock density 2.71, and the leaf coefficient is there. And different formations have different calcite concentration, dolomite concentrations, and different damage radius. Because if your well is too long, somewhere damage is 1 feet, somewhere damage is 2 feet, somewhere damage is 0.5 feet. So on the basis of your formation, You can change your calcite concentration. Like what we have to do is just change your calcite concentration and dolomite concentration and damage radius. And for second zone, we take 100. Okay, for first one, our damage is 90-10, and calcite concentration is 90%, dolomite concentration is 10%, and damage radius is 2 feet. And for second zone, our calcite concentration is 100 and damage is 1 feet. Okay, then quickly do the save button. So it will show you when you run the simulation, it will impact in your penetrations. Like if when there is a large damage, so that time you take more fluid, and when there is a small damage, that time you get using no fluid. Okay, now come to the reservoir fluid properties. In reservoir fluid properties, um, one basic fluid is there, that is oil. You can select gas, you can select water. When you select the gas and water, automatically your values and your according to the gas. If when you select the gas values is there. When you select the water some values is there. So we go for the just oil for this case. Yeah, and to the next bit. Now come to the user select availability. Means this is a pore flood analysis. If you are doing a lab experiment, and that time you get the PVPT and VIOPT's values. So you select here available, and you enter your pore volume, optimum initial velocity and optimum pore volume breakthrough, and your wormhole profile that comes in your lab. You can enter the values here. Or if you are not doing the core flood analysis, that time you select not available. So our model will run on the basis of, there are two models work here. One is record model and another one is Busey Glassberger model. So when you select on this tab like available or not available, our model will work on the basis of your availability or not availability. Now click to the next button. This is the last tab. This is pumping schedule. In pumping schedule, you select carbon dioxide injection at the time of acid injection or reflex injection. You enter your nitrogen injection, or you select both carbon dioxide and nitrogen. So we just go for the no form, and first we enter your pre-flush with a pump rate of 5, and the volume is 50 barrels, and then save it. Now this is a pre-flush. Now come to the main fluid. At the left side, see, in pre-flush we select fresh water. So the name of the fluid is here. In main fluid we select SCL15. The name of the fluid is here. We go for the pump rate 6 with 60 barrels. And then save it. Now come to the diverter. Diverter we select the in base case foam. So we go for the pump rate 7 with volume 70 barrels. Now come to the main fluid. We go for the 8 BPM with 80 barrels. Now our last stage is post flush stage. Or you can enter more the diverter and main fluid stage. Just go for the two main fluids and one diverter stage. In post flush, we select the fresh water. Oh, sorry. We go for the same pump rate. Yeah, with 80 barrels. And then save it. Our pumping schedule is filled. Now click to the next button. Data is saved successfully. You can run simulation. Click OK. When you click the run simulation button, just wait for a minute. Our data is processing and output is coming in a minute. Yeah, data processing completed. Now we get the results. Here in upper tab, this is a recommended jobs design table, 3D design, recommended recipe, and report option is there. If for base case, there is a penetration results. For diverter sensitivity, there is a penetration results. First, we go for the penetration. See, in upper zone, our penetration will go of approximately 4 to 4.5 feet. Okay. In lower zone, our penetration will go 0.5 to 1 feet, between 0.5 to 1 feet. Okay. So the first penetration is your first stage penetration, and after diverter, diversion will happens, and some fluid will go in this lower direction in next second stage. Now come to the injection fluid placement distribution. In this placement distribution, you check placement with diverter and without diverter. Like when you see, this is diversion is here. The last value you see, this part is your diversion part. Now come to the skin. In upper zone, there is a high penetration. The damage is clean, so your skin will goes negative. In lower zone, your the penetration is lower than the damage radius, so some skin is in positive. But overall, in upper zone, see the skin is negative, and here some skin is positive. Okay, so the total valuable skin, your average is 10. And now come to the average of whole formation, that is 0.78, means your skin from 10 to 0.78. Now come to the well productivity. We show you the PI productivity index, uh, how much your production will increase. The value comes in barrels per day per PSI. So the value is 2.14. The total production in different zone. Now come to the real-time analysis, or can say your treatment pressure analysis, where you check your bottom hole pressure, you check your friction pressure, check your pump rates, distribution, you check your skin on the basis of time. So all the graph is here, bottom hole pressure is there, simulated treatment pressure is there. You can check your values. Now come to the invision profile. Invision profile means it show you the penetration, means the fluid will flow inside your reservoir, how much it will flow inside your reservoir, different fluids. Like one is pre-flush. Pre-flush is upper part, and now come to the main fluid, then the diverter, then main fluid, then post-flush. So, so means all the fluid that you have entered at the time of pumping schedule will here. How much go inside your formation these fluids. Now come to the diverter sensitivity part. In diverter sensitivity, we check the penetration. In diverter sensitivity, we select the foam diverter as base case, VS diverter, viscosified diverter. See the best diversion impact. Which diverter give you best diversion impact? So the red one is the give you the best diversion impact, and the red one is your particular diverter, because it will go more lower direction. So it will show you which diverter is give you the best diversion impact. Like viscosity, for viscosified diverter is only goes in upper zone. Now, come to the VS diverter, it will here, and now VS viscosified is here, and the particulate is here. So you see the best diverter there. Same thing you can see the placement, skin, and fold increase. Now come to the main tab, that is acid diversion sensitivity table. In acid diverter sensitivity table, you check your diversion happens in different formation. Like you see in this formation, 29.4% without diverter. But when we go for that VS classified, 28.3, VS 27.3 foam and particulate. See in sixth zone, 0% in without diverter, means all the acid will consume in upper zone. Viscosified, same 0%. means all the acid will come. But in VS 0.6%, 0.5% is here, but in particulars 1% is there. So you see the diversion happens in different formations. So that time you get the better understanding in which form your fluid will flow and which percentage of your fluid will flow. So this is your acid divergent table. Now come to the this tab. If you select wormhole profile available, that time you enter your PVBT, VIOPT value. That time wormhole tab will open. Now come to the recommended job design table. In recommended job design table, we recommend you in what is your maximum pump rate, what is your maximum pressure, what is your volume that required for doing this simulation job. For this case, maximum pump rate is 13.38. So we go for the less than 13.38, and your maximum injection pressure is 4175 psi. And in acid volume per feet means recommended required acid like 4.87 barrels per feet you have to require to clean all the damage. Okay, guys. So pre-flush fluid 50 barrels you need. Main fluid you need 974 barrels. Post flush fluid 157 barrels, and tubing displacement 2.0205. Here is your concentration, here is your viscosity, and here is your maximum pump rate. So you go for the many times you go for the lower than maximum pump rate. If you exceed your maximum pump rate, your fracture pressure will happen. Okay, so your fracture is created because your bottom hole pressure will go for the fracture pressure. So fracture will create. So you go for the less than your recommended pump rate, because here we recommend only the maximum pump rate. What is your required for maximum pump rate? Now come to the recommended recipe. In recommended recipe, you use this surfactant corrosion inhibitor at the time of pre-flush, some chelating agent at the time of main fill, and your soaking time is 60 minutes. So this recipe on the basis of your mineralogies, your temperature, your pressure that you have entered in different data means tabs. So this recipe will come on the basis of your inputs. Now come to the report. When you click this report tab, report will open here, and in this report, different inputs that you have to enter in your mm, tabs. All the inputs is here, all the output graph is here. See, all the inputs are here and all the output graph is here. You can download this graphs in PDF form. If you want to download this graph in PDF form, so you can click and download this graph. So all the graphs in PDF form. Okay, guys. So this is our StimOpti software description. How can run your how to create a project, how to enter the inputs, and what are the results, how to check the results. That's it, guys, from my side. Thank you so much.